Good morning to all. My name is Yashish Shafias. I am studying second year BTech in Electrical and Electronics Department in Srinivas Ramanujan Institute of Technology at Anantapur. Today my topic about phasor diagram and equivalent circuit of auto transformers in the subject of DC machines and transformers. Phasor diagram and equivalent circuit of auto transformers. Firstly, we introducing to auto transformer. Auto transformer are a type of electrical transformer that uses a single winding to perform both set up and set down voltage transformations. They are commonly used in applications where voltage regulation is needed and space is limited. Understanding the phasor diagram and equivalent circuit of auto transformer is essential for analyzing their performances. Basics of auto transformers. An auto transformer consists of a single winding that serves as both the primary and secondary winding. The voltage transformation ratio is determined by the turns ratio of the winding. Auto transformer are more efficient than traditional transformer primarily due to their reduced copper losses. Phasor diagram overview. A phasor diagram represents the relationship between voltage and current in AC circuits. It is a graphical tool that helps visualize phase differences, magnitudes, and relationships in the circuit. In auto transformer, the phasor diagram illustrates the input and output voltages and currents in relation to each other. Phasor diagram of auto transformer. The primary voltage V1 and secondary voltage V2 are represented as vectors with specific magnitudes and angles. The phasor diagram also includes the load current IL and magnetizing current IM to show their relationships. The angle between primary and secondary voltages indicates the phase shift caused by transformer's operation. Equivalent circuit of auto transformer. The equivalent circuit simplifies the analysis of auto transformers by representing them with a few essential components. It is typically includes resistance, reactance, and the core loss component to account for real world inefficiencies. The equivalent circuit can help engineers calculate performance metrics such as voltage drops and efficiency. Components of equivalent circuit. The equivalent circuit includes the primary winding resistance R1 and reactance X1, which represents copper losses. The secondary side includes resistance R2 and reactance X2, which similarly account for the load losses. A core loss resistance RC is also added to represent the energy loss in the core material due to hysteresis and eddy currents. Voltage and current relations. The relationship between primary and secondary voltages can be expressed as V2, V1 where N is the number of turns. The current in the primary and secondary sides are inversely related to the turns. I1 by I2 equal to N2 by N1. Advantages of auto transformers. Auto transformers are generally smaller and lighter than traditional transformers for the same power rating. They proved higher efficiencies due to reduced copper losses and low operating costs. They are particularly beneficial in applications such as motor starting and voltage regulations in electrical systems. Limitations of auto transformers. Auto transformers present a safety hazard as they do not provide electrical isolation between the primary and secondary sides. They are less suitable for high voltages applications due to the risk of arcing and insulation breakdown. Their application is limited to scenarios where the voltage difference between the primary and secondary is not significant. Conclusion. The phasor diagram and equivalent circuit provide critical insights into the operation of auto transformer. Understanding these components aids in the optimal design and applications of auto transformers in various electrical systems. Continued advancements in transformer technology will likely enhance the efficiency and functionality of auto transformers in the future. Thank you for giving this great opportunity to me.